Hello, welcome to lesson 18. In this lesson, I will be talking about maps in Erlang. Maps are used to store key value associations. So, for example, username and a score. So then the username could be a key and the value could be a score. Internally, maps are stored as ordered collections in Erlang. And if you are coming from imperative languages, you may know maps. For example, in Python, these are dictionaries, um, or the hash map in Java. So the map, to create the map in Erlang, you write something like variable and then hash. And within this hash, there is a key1, for example, op value one, and then comma. So this is the first association in your hash map, and then the second, for example, key 2 op value 2, and then and so on, and key n op value n. So why I wrote op? Because there are two possibilities for this um, op. It could be either this thing or something like this. And I will be talking about this in examples. So let's go to Erlang shell as always, and let's define some example. So let's say we have scores map, and let me define it like this, and I will write here, for example, yeah, it would be like John, and then, for example, 100, Adam, 115, Sarah, 120. Let's say these are our associations. So this is the first association, key value. So the key is John and the value is 100. Here key is in second association. There's key is Adam and the value is 114. And the third association in our map is Sarah, and it's 120. So in this case, I'm using the keys. The atoms are used for the keys, and integers are used for the values. When I press enter, the map was assigned to my variable scores. Now, it's also possible to use as a keys non-atomic values. So in this case, let's say I have some three tuples. Let's say I have John tuple, and this will represent for me, let's say, oops, I need to, I think, forget. Is it forget? F, maybe to remove the, yeah, okay. F is to forget the variable, or to, in Erlang shell, you can use it to unbind the value, and now I can reuse it. John tuple, and let's say that John tuple represents the name John and the age 21, let's say. And now we have Adam tuple, so this is the second tuple, and then we have similar structure, name Adam and the age 20, for example, and we have Sarah tuple, and then we have name Sarah and age 22, for example. I'm creating this tuple to demonstrate that I'm also able to create use these tuples as key for my map. So let's say I will create now scores table, for example, and this will be something like this. This will be the values will be the same as in the previous example, but now I will use as a keys. I will use these tuples. John tuple, and the score was 100. Adam tuple, the score is 114, and Sarah tuple, and here the score was 120. Okay, so as you can see, I created the map, and in this case, we have non-atomic keys. So this is no longer atom. This is the tuple. So this is more complex key, and I can use as a key. Maybe let's check what I cannot use. So for example, I have score table and one, let's say, and I have um, maybe let me clear my screen. I have some tuple A. It's fine. B is unbound, and let's see if I will be able to create, for example, map C where A is okay, right? A will be 1, for example, and B will be 12. Okay, in this case I cannot use it as a key, so just to verify that this is not possible. And now I also can do, for example, I have my let's say simple map D. It will have maybe Adam, 10, and John. Let's say 22. It could be also something like scores or anything else. And now I can write something like this. D. I want to demonstrate for what purpose I'm using these two different types of operators. So as I mentioned, I can use operator like this, which I'm using here, and I can use also this operator. So I will first demonstrate the difference on this example. So to update now my map, I can type something like this, and I will type, for example, Roger 30, and I will assign it to the new variable e, and it will create for me new map based on existing map. It will take all the keys and the values from old map, and then it will add also this new association, and it will assign it to this variable e. So now e has 3 associations. So as you can see, this one, even though this one didn't exist in original map, it was created as a new association. Now let's use the second operator, and I have my, let's say, map E, and here I want to write Anna 31, let's say. And as you can see, I got error. Basically, I got error in the maps update function. Basically, due to the fact that Anna key um, does not exist in my map, I'm not able to update it. This operator basically updates existing key, while this will either update existing one or create the new one. So if I would type this thing, it would add Anna to the map. Similarly, I could create something like this, and now I could type 30 Anna 33, and now a value of Anna was changed to 34. While this thing, if I would write now, for example, 40, it's perfectly fine because Anna key exists in this map. Now, if I would like to use it for non-existing key, for example, David, I got the error. Basically, this key doesn't exist. Bad key error. As you can see, David does not exist. So the benefit of using this operator is when you always want to make sure that you don't misspell the name of the key, the key. So if you, for example, would you have Anna, for example, it's fine. But if you misspell and write something like Anna, you will get the error. While this thing would just add the new. Okay, in this case, of course, I need to create new map. But in this case, as you can see, it just created the new entry, which in my case, I didn't want to add new entry. I wanted to update Anna, this one, but I misspelled it and it was added. So if you want to always make sure that this thing exists in the map, you need to use this operator. Um, in this case, Anna exists. Yeah, this operator, okay, it exists. And the second benefit is, let's say, the internal implementation of maps has something called key descriptor, which is shared between maps. And if you have two maps with the same keys, and then you are changing this value, this association using this operator, it will use the same key descriptor. Therefore, if you have millions of maps, for example, they will share the same key descriptor, which is the memory. Of course, you save the memory because Erlang does not need to create multiple key descriptors underneath. Also, you probably noticed that every time, since Erlang is functional programming language, every time I'm creating map, this will be empty map, and then I want to change something in A, for example, by typing A John 10, for example, I want to create something like this. Now, if I will type A is still empty. When I type this thing, it created the new map, so I need to assign it to the new variable because I cannot modify existing map because in functional language there cannot be side effect. Okay, so the good practice is always use first time this operator, and when you're modifying second time is to use this operator, so you make sure that you're you don't misspell the name of the key, and you make sure that Erlang does not create new key descriptor underneath, so that you save memory. Right. So pattern matching is also possible with maps. So to do this pattern matching, let's say I want to extract this thing from this B map. So I want to extract this value. So for this, I would write something like this. I'm using this operator, and I want to assign it to name, to value, for example. And then here I'm typing from which map I want to extract, so from C. Now value or the score or the will be assigned to this value variable, and it's 10, as you can see here. So this is the pattern matching, which you can execute on maps. And there is a set of built-in functions which you can use with maps, and now I will demonstrate a couple of them. Let me clear the screen and run Erlang shell once more. So first beef you can use is maps new, and this is the equivalent of typing, of course, something like this. Next is to check if you want to check if given a variable is a map, you can type is map, and it will give you information that if it's a map, of course, it will give true. If this is not map, in this case it's string, it will give false. I can also convert map to list. Let's say I have my map. Now using function maps to list, I can, and passing this map as argument, I can convert it to a list of tuples, in this case key value associations. I can also do similar thing, and now I will create my L1, a list. I can also type opposite direction maps from list to convert from the list to a map, and then it will convert such a list to a map. I can also check the size of my map. This case is three associations. I can check if the map has given key, and then I'm passing, for example, A my map, and it tells that such key exists, B also, C also, and D gives false because I don't have such key in my map. I can also invoke get to get the value of the key. So this is the alternative to the pattern matching. I can, if this value doesn't exist, I will get bad key. Um, I can also try to find the value in the map, and it will give me either OK and the value if the key exists in the map, or error if the key doesn't exist in the map. To get the list of all keys in the map, I can type something like this. Okay, I get my list of keys. I can also remove the key from the map. I want to remove A from the map, and I get new map B and C. And keep in mind that the original map still has these three keys. So I need to assign it to my new map to see the state changed. What else I can do? I can, for example, take the map based on existing map. I can create a new map without certain keys. So let's say I have my map without B and C, and then I can type maps without, and as a first argument, then I'm passing the list of keys which I want to remove. So I want to remove B and C from my map, and then I stay with only one association A equals 10. I can also now execute maps difference to get the difference between two maps. So I will do something like my map and my new map. Um, Maps. Okay, in this case, something doesn't work for this beef, so let's maybe skip it. So this is it. In the next lesson, I will be talking about a JSON bridge for maps. So it basically allows you to generate JSON. So you can convert map to JSON and convert from JSON to map, to Erlang map. This will be especially useful for um, some web servers or WebSockets use cases. And I would like to also build some bigger example, which will be simple key value store based on processes and maps to show how to use maps inside some simple Erlang server. And this will be this I will show in the after next lesson. So thanks for listening and stay tuned for other videos. Cheers, bye bye.